Okay, I'm going to review the medians, altitudes, and perpendicular bisectors that we talked about right before the break. So I'm just going to go through that handout that we did on the Friday. So if you already have it, it's you're fine. But if you were not there, I posted a blank version of this if you want to go through it and fill it in on your own. So we talked about different types of lines and line segments that are found inside triangles. First one was a median, and all a median is a line segment that is between a vertex in a triangle and the midpoint of the side opposite that vertex. Okay, so it's connecting from a vertex to a point on the other side of the triangle that is the midpoint of that opposite side. And inside a triangle, there are 3 of these types of medians. So you could have a median coming out of every single vertex. And they all intersect at one point, which is called the centroid. How we found the actual median itself was through a process of a few steps. I'm going to go through with the example that's here. The process was already written here. This says if we've got this triangle ABC that I've kind of drawn out here, that's at A, B, and C for those coordinates, determine the equation of the median from vertex A. So I've kind of drawn out exactly which median I want. So it's coming out of A to the midpoint of the side BC. So the first thing that we'd have to do is find the midpoint of BC. So I can take B and C with the coordinates that are there, and then I can find the mean of the x coordinates and the mean of the y coordinates to find where the coordinates of the midpoint are going to be. And then it's now just using that process that you guys did in grade 9 of getting the equation of a line between 2 points, because I now know where A is, it's at -4, 7, and I now know where the midpoint is, it's at 2, -2. So in order to make the equation of the line then, what I could do is get its slope using the slope formula that you guys had from grade 9, the y2 minus y1 over x2 minus x1. Calculate that in its lowest terms. Then in order to make the full equation, I need to get the y-intercept by plugging in the slope we just found in y equals mx plus b as the m. And either of these 2 points I could plug in for the x and the y because both of them satisfy the equation. So I've just chosen to plug in the midpoint, but I could have easily have plugged in a. And I have now rearranged stuff to solve for b. So now I know the slope is -3 over 2. The y-intercept is 1, and then I can put it together in y equals mx plus b, and that's the equation of my median. Okay, so this is the first of the types that we were talking about before the break, median. If you flip the page over, okay, and we can start talking about altitude. What an altitude is, similar to a median, is it's the line segment that comes out of a specific vertex. However, it doesn't go to the midpoint of the other side necessarily. It connects to the other side at a right angle. So, like the other one, there are 3 of these types of line segments that can come out, 1 from each vertex. However, unlike medians, they're not necessarily going to a midpoint. So I don't necessarily know exactly what point this is connecting to, and that's kind of the trickier part of dealing with altitudes. What we do know is that relative to the side it's kind of trying to connect to, it has to be at a right angle, so it's perpendicular to that side. So like the other one, we have a process that's written here, but I'll go through with the example. So here, if they said, given the triangle ABC, like I've drawn out here, with A, B, and C, determine the equation of the altitude from vertex A. So here's vertex A, here's my altitude coming down. I don't really need it to go extended beyond, that's not helpful. And what I am going to need to do, like the other one, I need to find the slope for this little line segment and the y-intercept. What I can do in order to find the slope is, since I know it's going to be perpendicular to this side of the triangle, then I can find the slope of this side because I know what B and C are, so I can get its slope. So I found its slope from B to C, and then I can find the perpendicular slope, the one that I do want, just by taking negative reciprocal, like you guys did in grade 9. So if I found the slope here between B and C, I've calculated that to be 1 over 4. Our slope, the one we need, needs to be the negative reciprocal, so flip that, change the sign, so -4, and then make the rest of the equation. Plug in the slope we know, plug in a point that's going to be on this line segment, and the only point that I know is A, because I don't really know whether that actually is happening yet. So I can plug in A, the -2, 5, for the x and the y that's going in there to get my y-intercept. And then, lastly, put everything together in the equation. I have the slope, I've got the y-intercept, so I've got my y equals mx plus b. And that's altitude, more commonly known as the height of the triangle, but altitude. Like median, there's one coming out of every single vertex. Okay? And then the very last one that we went through was a perpendicular bisector. So this is a line, not necessarily a line segment, that is bisecting a side of the triangle, which means it is going through the midpoint. That's bisecting, it's cutting it in half. However, it's also a perpendicular bisector, which means it's going through that midpoint at a right angle. So this is kind of using pieces from median and altitude and combined side of a vertex. It's using that it needs to be perpendicular to a side like altitude did, but it's just combining those little two pieces. And like the other one, every side has a perpendicular bisector from this triangle, and they will all intersect at the same point too. Process is a little bit more involved here. There's a few more steps, but once you kind of understand what's going on, then this should flow fairly easily. So I'll use the example to kind of illustrate this, and it's always good to kind of draw it out so you can see what's happening. So here it says, given the triangle ABC with this A, B, and C, determine the equation of the perpendicular bisector of BC. So this is the side that I want the perpendicular bisector for. So that means the equation that I'm making for this line, so I guess line, is going to be needing to know the slope. So I could do what I did with altitude, is I could find the slope here from B to C, because my slope has to be perpendicular to it, so I could take a negative reciprocal. But I also need to know the point it's going to go through, which is the midpoint. So I'm going to do this pretty much in any order. I could find the midpoint of BC because I need to know a point that this line is going to go through. I need to find the slope of BC so that I can take its negative reciprocal to find the slope we do need. So I found the slope here to find the slope here by taking the negative reciprocal. And then, like the previous one with altitude, as soon as I know a point to go through, a slope that I can use, I can plug things into y equals mx plus b. I've got the slope in for m. I've got the point in for my xy to find the y-intercept. Now I can make the equation y equals mx plus b, with this being the m, our slope, this being the b, our y-intercept. And that's our perpendicular bisector.